In this video, we're going to be looking at congruence through constructions. Now, what we'll be looking at is constructing segments. We're going to be looking at triangle congruence. We're going to be looking at side-side-side congruence condition, or SSS, and then side angle side property, or SAS. And also, we'll look at some selected triangle properties, construction of a perpendicular bisector of a segment, and construction of a circle that's circumscribed about a triangle. Now, in this case here, we won't go into a lot of detail about the concept of constructions because there is software like the GeoGebra and the Geometry Sketchpad that does do actual constructions of certain figures. All right, we're going to talk about congruence and similarity. Okay, so here, this is just an illustration of congruent fish and congruent birds. They have the same size and the same shape. So congruent figures have the same side and the same shape. Now with similar triangles, in this case here for this illustration, you have the same shape, but not the same size. In other words, this big triangle right here is the sides on each of these triangles here have twice the length as, let's say, this triangle right here. Each side of the big triangle has twice the length of each side of this small triangle here. So has the same shape, but it's not the same size. Okay, so here's the definition of congruence and similarity. Similar objects, which is denoted in symbolically as just a simple squiggly line, have the same shape, but not necessarily the same size. And then congruent objects, which is the equal sign with the squiggly mark on top, has the same shape and the same size. So in this case, you can think of congruent objects are similar, but similar objects are not necessarily congruent. Okay, a definition of congruent segments and angles. In this case here, line segment AB is congruent to line segment CD if and only if the measure of AB is equal to the measure of CD. Okay, so if line segment AB is congruent to line segment CD, then the measure of AB is equal to the measure of CD. And also, if the measure of AB is equal to the measure of CD, then we can say that the two line segments AB and CD are congruent to each other. And then the second statement, angle ABC is congruent to angle DEF if and only if the measure of angle ABC is equal to the measure of angle DEF. So the phrase if and only if means that if this is true, then this is true. And also if this is true, then that statement is true as well. Let's talk about triangle congruence. Two figures are congruent if it is possible to fit one figure onto the other so that matching pairs coincide. Like this triangle right here, ABC. Okay, if I'm able to fit this triangle, A prime, B prime, C prime, on top of this so that the matching pairs correspond to each other, then that means that these two triangles are congruent. In other words, in this case, angle A is congruent to angle A prime. Angle B is congruent to angle B prime. Angle C is congruent to angle C prime. And also, side AB is congruent to side A prime B prime. Also, side BC is congruent to side B prime C prime. And also, side AC is congruent to side A prime B prime. In this case here, we can conclude that triangle ABC is congruent to triangle A prime, B prime, C prime. Okay, let's look at congruent triangles here. Triangle ABC is congruent to triangle A prime, B prime, and C prime, which is written as this. This is a symbolic notation of writing a statement where triangle ABC is congruent to triangle A prime, B prime, C prime. And that's if and only if angle A is congruent to angle A prime, angle B is congruent to angle B prime, angle C is congruent to angle C prime, line segment AB is congruent to line segment A prime, B prime, line segment BC is congruent to line segment B prime, C prime, and line segment AC is congruent to line segment A prime, C prime. So in other words, we can say that the corresponding parts of congruent triangles are congruent, which is abbreviated as CPCTC. Okay, here we want to write an appropriate symbolic congruence for each of the pairs. Okay, let's look at this pair of triangles here on the left-hand side. We got triangle ABC and triangle EFD. Okay, so one way that we can write it is this. Triangle ABC, as I mentioned, is congruent to triangle EFD. Now keep in mind the naming of one triangle has to be consistent with the naming of the other. So on the left side, if I'm going to say triangle ABC, then I must also say for this triangle EFD. I could have said triangle ACB, but I must say triangle EDF. Okay. The way you name one has to be the same